Hey, hello guys. How you doing? Can you hear me well over there?
Yes, bro.
Okay, cool. Thank you guys for joining. Let's start. I said we would start at 10:10, so just honoring that statement. And well, just here you had a time later. You can say, and I will also put or post in Canvas that this session is actually being recorded. So it will be published in Canvas at the end. So thank you for joining, and let me just start sharing so we can start with this thing. It's just an hour, so I think we'll take advantage of the time. So, okay, can you see my screen, guys? Just can you please confirm?
Yes.
Okay. Thank you. I'm testing a new microphone. If at some point something fails, please feel free to speak up and say it that you cannot hear or you have some trouble with this. Okay, let's start. What I wanted to start with is basically this. Today, I mentioned that we could be adding some details about deliverables. I'm finishing this, guys. Please allow me the rest of the day. I'm well sending emails there and there to the professors, just making sure we are in the same agreement. So you will see details about the deliverables we are having on this project we are working on. So I think something happened with my camera, but I hope it works. Okay, if I try again. Okay, it's not working. Okay, so yeah, guys, please expect an update here in this section, the challenge where it says catch the rover. You see there the last session we had with Nuclea is already there published. So more links will be there. So they will have the due date, the end of the class and all those deliverables you are given. I think there are two deliverables. We are actually agreeing on this, but well, you will see that later today. Other thing that I wanted to mention is on last class, I forgot to explain this part of the section. Maybe you recall we saw all this content, all the transformations. We went, let me go back a little bit. We went to all this content, graphics functions, libraries. We saw a list of graphic packages. Then we went something about OpenGL, ModernGL, Pygame. Well, the rest of the things we saw was about primitives. It was on first week that we saw primitives. Remember, we saw points, we saw then lines, curves. They are coming on this week. I think we're gonna see those on Thursday. We are seeing curves, and we also saw field areas, some attributes for our primitives. But what else? Something was missing here that was about user interfaces and events. So I just want to finish this topic so you have enough for the laboratory or the exercise you are doing this week. And I'm gonna explain or take some time for explaining the rest of the laboratory in case you have questions about the exercise you are doing, guys. So I will provide the time for this. So just give me a second. I will try again to fix this camera. Okay, changes to the, let's see if this works. Okay, it works, I think. Okay, so user interface and events. The idea with this is basically that, just a quick question. You are seeing this, the presentation, right, guys? The user interface and events, right?
No.
Oh, what you are seeing, guys?
The announcements of Canva.
Oops, sorry. The things that I have 3 screens here, so I was sharing the wrong one. Give a sec. I think this is gonna be the one. There you are. Did you see there the presentation?
Yes.
Okay, good. Sorry, guys, I was presenting other. Okay, user interfaces and events. When we talk about interactions with the applications, the graphics libraries or the graphics packages will provide this way of interacting and giving some input to our applications. So in the exercise I gave you on last week, you will try to implement something with 2 devices. In this case, it's going to be the mouse. So you are trying to emulate the shear effect or transformation, and you will also use the keyboard for selecting the transformation you are working on or the one you want to show there in the screen. So they can be these input devices can be classified in these 6 classes. So you can see we have locators. It basically defines a position. We have the stroke. It's also used for setting now a set of coordinates. We have the string. You see it is basically, well, the simplest device we have for strings is basically the keyboard. That's all. Then we have the valuator that works in a scalar value. So you are increasing or decreasing the value. You have the one for choice, or in mind, you have an option, you have different options, a menu of options. So you select with this kind of devices. And we also have the pick. Now, if I ask you which, well, in which categories we can see the mouse, the mouse we use in our computers, or the how we call it, the pad you have in your laptop. In which category do you think we would have the mouse? Anyone would like to comment on this? Where do you see the mouse located in these classes? It will be in more than one, but which one should you think? Anyone?
Could be locator.
Locator, yep, it is locator. What else? Anyone else thinks another could apply for the mouse?
Another one can be pick.
Pick, yep. It's for selecting a component of a picture. Yes, pick. Did you see? Thank you, Ingrid. Did you see? Yeah, the mouse can be, I think, in most of them. The only one that actually doesn't apply because the mouse doesn't have this capability of specifying text input is maybe could be a string. No, but for the rest, we could say a mouse could be, located in most of the classes. So these are the classes, guys, we have for input devices in user interfaces. So yes, let me see the chat. Someone asked something. Okay, you were putting some comments. Okay, DALL-E, stroke, locator. Okay, good. Thank you for the chat. I just opened the chat so I don't miss messages. Okay, so when we talk about how we interact, we have also these modes. The first mode we're gonna have is this one that we call it request mode. So the program just starts, and every time that you put an input, let's say you click something, you select something, you move or drag something in the screen, imagine this, the program is kind of stopping the execution or suspending the execution, receives the data, and then continue with the execution. It takes an action based on whatever you specify, no? So, and it says, no, processing is suspended until the required values are received. So this is the first one. Then we have the sample mode. So this is the one that is pretty interesting, and this is actually the one we use most today. It says the application program and input device operates independently. So imagine this, your program is running and you have another, we could call it a thread or another process that is taking all the input that is coming from your input devices. So they may work at the same time. They have communication mechanisms. So you connect your application with your input devices process, so they can interact. And if it receives something from the input devices, it does something in the application or whatever it's showing on the screen, or some effects, some movements, or some transformations, or whatever we are doing there. The last mode we have is event mode. It says the input devices initiates data input to the application program, and then says the program and their devices again operate concurrently, but now the input devices deliver data to an input queue, also called an event queue. This mode is kind of interesting because it's kind of a mix of the previous two we saw. And in this case, imagine, since we may have multiple input devices, the application should be able to receive all those instructions, all those events, and do something based on whatever the input devices are indicating. So that's why this kind of programming requires this event queue, which will manage the way we are treating, or we are consuming those events we are getting. Something that is pretty interesting here is that there's a whole set of software components for these event queues. There are many projects for doing this queuing. There are companies that are dedicated only for doing this queues management, because it needs to be performant. So if you do click or you do type something in the keyboard, you need super fast response, so you don't see some lag when you are interacting with your user interface. So it's pretty interesting how it works. And when we talk about also about sampling mode, I want to mention this. In some graphics libraries, they will have this concept of sample rate, which means how frequent you want to detect events on that machine. I mean, in those input devices. No, for example, I don't know if you remember those machines. Let me see how they. I don't remember the name in Spanish, so I will Google it in Spanish. But let me see if you remember those things. We call it maquinitas, but I don't know if you remember those things. They call it arcade things. I don't know if you have something like this in your home today, but I have seen some students that they still have these things. I didn't play these things a lot when I was younger. My parents didn't allow me, but well, the things that these kind of devices, guys. Well, this sample rate is based on that thing of, I don't know if you remember that you were like touching super fast the buttons there. So based on that thing of how I don't know if you remember that I used to see my cousin doing this. He did like super fast, and depending on how fast he did that, pressing that button, some combos or some effects they can perform there in their fight or whatever game they were doing. So this sample rate specifies not that configuration that will say, okay, we support this number of inputs for every second, no? So it's basically based on seconds, no? How many events per second you are able to handle, no? So it's pretty interesting how it works and from where these kind of configurations are coming, no? So if you don't have a machine like this, well, it's just something that you may have. They are not like having the perfect graphics, but it's kind of cool. The other day I went to a trip somewhere in the goods, and they have this machine in the place that we rent, and it was pretty cool to remember those times. Okay, so those are the input modes we have for user interface, like the general ones. Sometimes you will see combinations of them, as you see the event mode. So there's something that I like to mention here is that, let me Google it if I am correct. It's event driven, yeah. There's something that comes from this event mode that we call it event driven programming, or event oriented programming. So it's actually now a way of programming, no, based on events. So nowadays, when we do our software, we use many combination of techniques, but this is like one of the common ones, no, event-driven programming, because it's basically detecting events from whatever input device we have today, and sending those events through these queues, event queues, and consuming those queues. Also nowadays that we have multi-core capabilities in our systems, so those queues can actually be read from multiple agents or consumers. So we can do, many things with this event-driven programming. I would recommend you to take a look on this and search some programming languages that are actually designed for this event-driven programming. Even when you can do it in whatever language you want, there are some languages that will have, more. They will be more mature for doing that kind of programming. So, okay, let's finish this. The last piece here is I have in this case, it's an OpenGL program, a C++ program that we usually present in this. Just to give an example of this, I will go through this a little bit, and I will try to, you know what, I will open the console, it will be better. Give me a sec, terminal. Okay, downloads. I'm downloading the mouse. Okay, I think there it is. I like the colors there. Okay, so in this case, we have a program. Okay, you know what? Give us a second. Okay. I will divide this thing in two so I can compile it and run it. I don't remember how to compile this. Oops. Give me a second. I want to get. Oh, I think I have it here. Plus plus. Okay, there we are. Mouse. File it, and then we'll try to run it. This program is doing something super simple. It's an OpenGL project that for every time that I click in the screen is drawing a coin. It's not a big deal, but the only thing that I like to present quickly here is the code to do that. It's a super simple things. Nowadays we have functions that is just, as you remember, we have functions that in, or values that in processing for getting the mouse coordinates. So we also have functions for getting the button that you just pressed. But in OpenGL, we have this we have these functions, or these constants that are defined. Actually, no, they are not constants, they are variables that they will be updated as soon as you do this kind of events. In this case, for every time that you, in this case, click or press the left button, these variables will be updated so you can do something there. Remember that I mentioned that OpenGL has its core, and every function or every utility you want to use from OpenGL core will start with GL, as you see here, this variable, this data type, GL and something. In this case is GL int. Many libraries will do this. Sometimes they do some modifications to the data types. So that's why they define their own data types. We can say, why we just use int and that's all. No, the thing is that they sometimes use a specific data types. Sometimes they are optimized. I don't know. It depends on the framework or the library. But if you see GL something, it's OpenGL core. No, so if I go back here, well, it's not included there. It's included GLUT, and GLUT include GL that H, so everything is there. But for every function like this, GL clear color, GL matrix mode, they are coming from OpenGL core. But there's another GLU that is also coming from OpenGL, but not the core, is like an extension. But we also have GLUT. I mentioned, I think it was, I don't know if it was in the first week, I think. GLUT is the library or the software, the software package we use for user interface interactions and also for displaying the user interface. So GLUT is gonna be the utilities or set of utilities we will use for, in this case, for the input. So that's why you see GLUT underscore something, no? So it detects that you click the left button, and also it detects that the button was down. There are other events. For example, if you release the button, there's another event that will be also triggered. So you can detect all those events, guys, and do interesting things with that input. In my case, you're gonna see it's super simple. What I'm doing here is basically every time that I click, I'm just plotting a point, and that's all. Not a big deal. So I just wanted to show that. But the last piece here, okay, there's again, GLUT is the library we use when we do programs with OpenGL. GLUT is the one for interacting. So we have this callback for every time something happens in the mouse. Well, you have a function that will handle that event, no? So guys, just a quick question. Do you know what's a callback? Maybe you have used callbacks, but you remember where or in which languages you use callbacks? Someone would like to participate? Where do you use callbacks? Anyone? Ideas in chat, or you can speak up in your mic.
I have used them in SQL.
In SQL, callbacks. Okay, what's the scenario there, Lily? How you use callbacks there?
It's like creating a table and then to use callbacks. I do not quite remember quite good, but it was like calling an another like transaction from another table.
Good, good. Yeah, so sometimes from my experience with databases, I recall we do something like for, I don't know if it was a similar scenario with you, Lily, but I remember this. I think we call it triggers, or I don't recall the name of the things, but if they were callbacks, well, they were callbacks. But the thing is that for every new row that you add to a table, you can trigger something somewhere else, as you said, in another table. That was one of my scenarios that I recall. For every, let's imagine, for every student added to the students table, so we do something in another table, no, maybe update the classroom size or something. Yeah, yeah, those are callbacks. No, based on an event, you do something else. No, in this case, we have a callback that specifies that every time something happens in the mouse, in this case, a click or a release, or we have the common case, we have 3 buttons in the mouse. So depending on the button you press, you got an event, you do something. No, other place that you use callbacks a lot is JavaScript. JavaScript also has lots of callbacks. They have a whole way of explaining this. I'm still a little bit confused sometimes. I don't know if you have used JavaScript. I heard that some of you use JavaScript, but you have sometimes these things that asynchronous, synchronous, and those kind of things. Sometimes I get confused with those terms, and when I'm doing JavaScript, I need more practice on that. So that's why when I do callbacks there, I need to test a lot to make sure that it works as I expect. But yeah, for this kind of interaction, we will use callbacks. No, so the idea of a callback is to run like in a separated. In most of the cases, we would like to work in a separated thread, so we don't affect the main thread of our application. So given this example, I like to continue. Let me see what else we have. Well, I will ask questions, guys, comments at this point. No questions, comments? Take a look on this. Well, it was a challenge we used to do in the past. I actually assigned this to the other group we are giving classes, but in your case, you are saved because on last week, I forgot to mention this, and we are already doing some interaction with devices. So we'll skip this challenge. So we will not do this one. Well, maybe next semester. Let me see what else we have here. Okay, no. Okay, I think that's all here. Well, we are done with the theory. The only missing piece, guys, before we leave today, I like to show some stuff in Canvas. For those that arrive a little bit late, guys, I mentioned that oh, the video we have with Nuclea is already there. It's a link to YouTube, so you can just go there and rewatch or the video in case you have questions. I mentioned that in the coming hours or the rest of the day, I'm adding more details about the deliverables, something that you asked me on last week. So we try to think on the weekend. We are just making last adjustments on this. So please allow me, I would say, if not today's night, tomorrow morning, they should be there. So you have, like the deliverables, the dates, and those things that you need for, knowing what you are actually delivering on this project. No, so I'm still also waiting for Nuclea's feedback on this. So thank you for your patience, but expect more details there. I haven't been in Discord. I will take a look. I received a message in my cell phone that I missed some messages, so if he just send me a message there, well, I will go there and try to answer as soon I log in there. The other part that I want to mention is about the, where is it? Okay, here we are. If you go to the part 5, oh yeah, we have this lab or this exercise, 2D transformations that we started on last week, where we implemented, remember, the translate, rotation, scaling, and you also have the one for home. Let me open it. So you have to implement reflection and also shear X, shear Y. Those two guys, I need those implemented so we can actually play with this mouse interaction. So I want you to implement these ones with mouse support. So it means that if you click and move in X, so your figure there, the one you created before, will be shared. No? So you will apply this transformation. So you decide the way you implement it. I would recommend you to use the vertices as the places from where you are actually moving, because if you are drawing something different than a square, well, you need to decide which or how you are actually moving your vertices there. So it must support the mouse. So when I click and drag, we'll be able to see those effects on X, but also in Y. Yep. And we already in class we implemented this thing of moving our origin to the center of the window. It's already there. The only last piece that I don't know if I mentioned, but I like these guys. Assign a special character. I would recommend numbers for each to the transformation. So it means this. I did a super quick example here. Let me see, where is it? Okay, I think it's here. I don't have my program completed. It's basically what we did in class, but what I did here is this. For example, if I type, well, you cannot see, but well, I'm typing 0. My original figure is just drawn, nothing else. If I type 1 in my keyboard, I get, I think, translation, as far as I remember. Okay, with current options, I created a global variable, call it current option. So I get that transformation. If I type 2, well, it's doing rotation, no? The original rotation. If I do 3, well, it's using the rotation with a pivot. And then we have 4 for scaling. And then we have 5 for scaling with a fixed, oops, what I did here. If I do 5, I'm doing the scale with a fixed point. So yeah, I like this. So I'm able to interact with all the transformations you did, guys. Please, when you submit your homework, please allow me or give me there how to interact with your program. What I did, so I can see the difference, is to, in every transformation, please draw the original figure and also the transform one, so I can, differentiate, the effect or the transformation you are actually doing. In my case, for example, here, for this scaling, I'm scaling, on top of the, in front, sorry, of the original one. That's okay. Well, I will see the image like scale, so that's okay for that one. No, but for the others, I would recommend you to see something like this, so I'm able to see the effects. Emilio, you have a question? Could you? Sure, Emilio, no worries. So the way I implement this, guys, it's super simple. JavaScript, in this case, processing has a function for this. You call it a key typed, and every time you type every key there, you can trigger an exam something or update a value. So here you have the example, so you can just go to the reference, and there you have the way of implementing this. In this example, you have A or B, A, B. You see the different colors there in the figure. So guys, please take a look on this. Let me see if something else will be required. Oh, this is super important. I provided a link here or a document that will be useful. I would recommend you to download, because in that document, you will see the details about the algorithms you need, for example, for reflection. The algorithm, the matrix, the reflection matrix is there. So you have the formulas, and I think you will also have, the one for shear. So there you are. You have the formulas. So everything is there, guys. You don't need to do anything else there. So you have the matrix, the transformation matrix. So you can do it with matrices, or you can do it directly with the formulas that are actually being derived from the transformation matrix. So I think, guys, that could be all from my side. We will see each other on next Thursday. We are seeing a new topic, as I recall, because we already saw 2D transformations. I like to spend some time with curves, and I would expect if we to do something with 3D transformations on next week, or maybe this week at the end, but we'll see how it goes. Questions, comments, guys, and in general, or maybe about the deliverable. It's for, I think this one is for, oops, okay, I think for this Thursday. Yeah, it's for Thursday. Yeah. You still have time for doing this. Questions, comments, guys, before we finish. Everything cool? Complaints? Nothing, guys? Okay, if no questions, no comments, I really appreciate your time, guys. Thank you for being here. See you on Thursday. Have a good and super great rest of the week. Thank you, guys. I will stay a little bit more. There are some questions there that some of you want to address. I will say, let me just stop the recording.